What if you could hold the power of a star right here in the palm of your hand? I know it sounds like science fiction, but today we're going to dive into the facility that's doing pretty much exactly that, building a sun right here on Earth.
You know, for pretty much all of human history, astronomy has been a passive sport. We look up, we observe all the beautiful, violent, and mysterious stuff happening out there in the universe from an incredible distance, and then we try to guess the physics behind it all.
But what if we could just flip that script entirely? What if, instead of only looking out, we could actually bring a tiny piece of the cosmos down to Earth and study it up close?
I mean, seriously, what if we could replicate the very heart of an exploding supernova to see where gold actually comes from? Or squeeze a rock with the same insane pressure you'd find at the core of a distant super-Earth? Well, that is exactly what's happening at the National Ignition Facility.
Okay, so let's get into it. How in the world do you build a miniature sun? The process is called inertial confinement fusion, and it all happens inside this massive building. A building so large you could literally fit 3 football fields on its roof.
So it all starts with something ridiculously small, a target. This tiny little capsule no bigger than a peppercorn filled with hydrogen. This gets placed inside a gold cylinder, which has a cool name, a holram. Then comes the blast. In a perfectly synchronized, mind-bogglingly precise moment, 192 of the world's most powerful lasers all fire at once. But here's the really clever part. They don't actually hit the target directly. They hit the inside of that gold holram, creating this intense, uniform bath of X-rays, and that is what crushes the fuel capsule, causing it to violently implode and trigger nuclear fusion.
The conditions created in that tiny instant are, well, they're almost impossible to wrap your head around. The temperature skyrockets to 100 million degrees Celsius. That is a searing heat that is literally hotter than the core of our own sun.
And the implosion itself, it happens at a staggering 600,000 miles per hour. To put that into perspective, if you could travel that fast, you could get from San Francisco to Washington, D.C. in about 15 seconds.
And the sheer power involved is it's mind-boggling. For a few billionths of a second, those lasers deliver 500 terawatts of power to the target. And get this, that is 1,000 times more power than the entire United States electrical grid uses at any given moment.
But here's what's so cool. Creating this star on Earth isn't just about energy. The National Ignition Facility, or NIF, is also this revolutionary tool for cosmic discovery. It's kind of like a terrestrial telescope that lets us look inside the universe's most extreme objects.
This represents a fundamental, game-changing shift in how we do astronomy. For centuries, it's been observational. We see something happen light years away and then try to build a model of the physics. But now, it's becoming experimental. We can actually recreate that same physics right here in a lab to see if our models are even correct.
And this allows scientists to tackle some of the universe's biggest, most stubborn mysteries. Like, how are heavy elements like gold and platinum forged? Well, they can recreate the conditions inside a supernova to find out. Why does the Crab Nebula look so weirdly turbulent? They can model it. They can even simulate the cores of alien planets and test the nuclear reactions that might just solve the great cosmic lithium problem.
And this brilliantly illustrates the power of this new approach. Okay, so when we're looking for life on exoplanets, a key question is whether a planet has a protective magnetic field. We always just assumed that required a swirling liquid iron core, just like Earth has. But NIF experience showed that on these larger super-Earths, the pressure can get so intense that it makes the liquid rock, the magma deep inside, conductive enough to generate its own magnetic field. This suddenly makes millions of planets we might have previously dismissed as uninhabitable, well, potentially habitable. It's a huge discovery.
So as incredible as all that cosmic discovery is, NIF has 2 very specific, very down-to-earth missions. On one hand, it's a proof of concept for clean energy. Now, NIF isn't a power plant itself, but it proves that laser fusion can produce more energy than it consumes, which paves the way for future commercial reactors. And on the other hand, and this is actually its primary funding source, is national security. By creating a tiny contained fusion reaction, it allows scientists to study the physics of nuclear weapons and maintain the U.S. stockpiles safely without ever needing to conduct underground tests again.
And wow, on that energy front, the progress has been absolutely explosive. After they achieved that historic breakthrough of ignition in December 2022, that's when they got more energy out than they put in for the very first time. They haven't just repeated it. They've been shattering their own records, with recent experiments producing way more energy than they even started with.
But look, this incredible success, this didn't just happen overnight, not even close. It's really the culmination of a 60-year quest, a story of immense persistence, incredible ingenuity, and generations of scientists all chasing this single, audacious goal.
I mean, just think about this journey for a second. The core idea was proposed way back in 1957, before the laser was even invented. It took until 1997 just to start construction on the facility. And even when it finally came online in 2009, success was far from guaranteed. It took another 13 long years of failures and near misses before they finally achieved ignition.
The actual breakthrough happened at 1 a.m. on December 5th, 2022. And when the initial data came back showing this massive energy gain, you know what the scientists did? They didn't celebrate. Their first thought was that the sensors were broken. They actually spent days secretly checking and rechecking the math before they dared to announce to the world that they had done it.
And getting to that breakthrough required some unbelievable ingenuity along the way. Take this technique called ramp compression. It's one of their most brilliant hacks, and it's what allows them to peer inside other worlds. Instead of just hitting a material with a sudden, violent laser hammer blow, they carefully ramp up the power, gently squeezing a sample to millions of atmospheres of pressure while keeping it solid. That allows them to study the true state of matter inside another planet. Just brilliant.
So here's the bottom line. We are entering a brand new era of discovery. An era where our understanding of the universe is no longer limited by the distance of our telescopes. We have, for the first time, brought a piece of the cosmos into the lab. And you just have to wonder, what happens next? What becomes possible when we can not only look at the stars, but build them, experiment with them, and learn their secrets from the inside out?